In this section, we're going to talk about sequences. And for example, a sequence might be written in the form a sub n equals 2n plus 5. And all that is a linear equation, right? Y equals mx plus b. But we're just going to call this a sequence. So a sequence has domain, or the x values, or in this case the n values because we're using n instead of x. And it has the range, which is the a sub n. And for a sequence, we use the special term called term. Anyways, for the domain, a problem might say, find the first 6 terms of the sequence. So domains always start at 1 unless it tells you otherwise. So the first 6 terms will have domain 1, 2, 3, 4, 5, and 6. And we need to find the term at these specific domains. So it's really just making a table of values, right? Plug in the domain, getting the range. So plug in 1, you get 7. Plug in 2, you get 9. 11, 13, 15, and 17. That's really all it is for the most basic case. These get a lot more challenging when it gives us the domain and range, or the domain and term. And we have to develop the equation for it. So that's like the reverse part. It's a lot trickier. There are multiple types of sequences, and throughout the next few lessons, I'm going to show you some tricks to make it easier for you. But for some of them, there just really aren't any tricks, and that's what we're going to look at today, is one where you just kind of have to know what's going on. So we have one, and it's going to say, you know, here's the terms, 1 over 1, 1 over 4, 1 over 9, and 1 over 16. And it's going to say, describe the pattern, find the next term, and write a rule or an equation for this. So first we're going to describe the pattern. So how do they go from 1 over 1 to 1/4 to 1/9 to 1/16? It looks like the number on the bottom is getting squared. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. So that's what we're going to go with. They squared the denominator. That's describing the pattern. Okay. Then we're going to need to write the next term, which is 1 over 25. And now we're going to need to come up with a rule for how they got here. This is the tricky part. So we're going to start with a sub n, and we know they squared something, and they squared the denominator. So whatever it was, they squared it. So when the domain was 1, they squared it, and they got 1 over 1. When the domain was 2, they squared it, and they got 1/4. When it was 3, they squared it and got 1/9. So this is the equation to represent this sequence that they've given us. Now, this is what I want you to watch out for. When you see squaring and cubing, you really need to take that into account, because there's no real good rule for squaring and cubing. For some of the other types of sequences, there are some tricks, which I'll show you in the next lessons. But for squaring and cubing, you're just going to have to do some guessing and checking to get your right answer. But it's really easy to guess and check, right? You just plug in 1, then 2, and see if, you know, when you plug in 1, do you get this? When you plug in 2, do you get this? When you plug in 3, 4, that's really what you're checking, right? Because here's the domain, here's what they got. Domain, what they got. The last thing in this section is about series and sum notation. So here are two series, or sequences, I over I plus 1. Or we could say n over n plus 1. It really doesn't matter what variable we're using. It gets the same effect always. The way we read this is sigma, Greek capital sigma, Greek letter, which means find the sum of this series when the domain starts at 3 and it goes until 5. So it says find the term when the domain is 3, then add it to the term when the domain is 4, add it to the term, the domain's 5. So we're going to plug in 3 for all the places we see I, so 3 over 3 plus 1, plus, that's what the sigma is telling us to do, 4 over 4 plus 1, because we have to keep going until we hit 5, so 4 over 4 plus 1, plus 5 over 5 plus 1, and we're going to add those together, so 3/4 plus 4/5 plus 5 over 6, which is something like 2.383. So this is what's known as a finite series. It has a beginning and an end, finite. This is what's known as an infinite series. It starts at 3, but goes on for infinity. We can't add this together through a traditional method like this because we would never get to the end. We'll worry about that in some of the coming lessons.